So what happens with the inverse is it's just like they undo each other. And what I like to do is, I don't know if you had Emmy Houseman in elementary school at Newberry, but in first grade when Joshua had her, my son had her, she had these in and out boxes, or function machines is what we call them. And what happens if I have two functions that are inverses, oh, that's the other thing I probably ought to talk about, is this notation, f to the negative 1 of x. That's not meaning 1 over f of x. That's the reciprocal. This notation means what function undoes the other, or what is the it's like square roots and x squared. Those are inverse operations. You did a little bit of work last year with exponentials and natural logs, probably, ln x. Those are inverse operations. They cancel each other out. Back in geometry, you learned how to find the sine of a function with a calculator. And arc sine, if you look on your calculator, it's a little scientific calculator will even have this. They'll have the inverse sine. We call that the arc sine. You'll learn more about that later this year. But see, so it's not the reciprocal, it's the inverse. So what does it mean about inverses? Well, if they undo each other, now what happens? Let's get back to my function machines. If I drop 3 into this original function f, and I get 2 out, for whatever rule it is, I don't know, it could be anything. But then if the next function is the inverse of f, if I drop the 2 into there, I'm going to get 3 out. So what's happening is the old x becomes the new y. The new y becomes the old x, the old input. So the output becomes the input. The input becomes the output. I know it's a little confusing. So if I'm looking at this, I've got a function that's 1 to 1, so that means it's going to have an inverse, and we'll talk about that in a minute. And it has a domain that's x is greater than 2, and the range is y is less than 1. So if we're going to switch x and y, now I can say that the domain is going to be x is less than 1. Notice I switched the old y became the new x, and the range becomes y is greater than 2 for whatever graph, whatever function, whatever definition they have for us. Okay, but all you got to remember is you're just switching the x and the y. It's that easy, really. So keeping that in mind now, so we're going to switch x and y, and another element of this, one of the essential objectives, one of those learning targets that I wanted you to answer is to be able to work with this in English and symbolically. Well, this is the inverse function. This is telling me, find f inverse of 3, whatever the heck that means. Well, this is asking me what x in f of x has a y that's equal to 3. So what we could write is, we can, instead of writing f inverse of 3, we could write that and think of it as f of x equals 3. And that's exactly what this is asking us. It says what x has a y that's 3. So if we go on our table, the only place that y is equal to 3 is this point here. So x equals 1. That's the answer to that question, x equals 1. Now this is asking me a different thing. This says what y, whoops, be nice if I could spell, what y in f of x equals y has an x that's equal to 3. So I could write this as f of 3 equals y, or x. So f of 3 is 7, so the answer to that is 7. So what might help you in these kind of problems is to rewrite it so it doesn't have that inverse notation. And that might help you get into the groove of what's happening here, so you don't have to do that step. eventually. I still do sometimes. So again, now that we know what happens with inverses, and you're going to tell me what happens with an inverse, I hope you said we switch x and y. For this problem, if we know x is 3 and y is 2, then f inverse of 2 equals 3. We just switched the x and the y. That easy. So now we did an inverse off a table. Now we're going to do work with inverses off graphs. And I already asked you a question like this really in that very first quiz. You didn't know that. You didn't know that what I was asking, but it was very doable for what we knew. So this is telling me, all right, let's rewrite this as, where does f of x equal 3? Well, here's the line y equals 3. What x values have a y value that's 3? Well, when x equals 1, so the f inverse of 3 is equal to 1. And this is telling me, here, so this last one's telling me, so let's switch it. F of 4 equals what number? Well, if x equals 4, y equals 2. So written this way, I could say the inverse, f inverse of 2 does equal to 4, because that's what we know. So now we're going to actually find a formula for an inverse, and that's where we're going. So the steps are, first off, instead of writing f of x, let's write that as y. So y equals 3x minus 5. And now we know when you find an inverse, you can switch x and y. So x now equals 3y minus 5. Desmo will graph this. You really don't have to go any further. Graphing calculators won't, so we needed to go a step further. And honestly, you want to have it solved for y anyways. So what I'm going to do is I'm going to add 5 to both sides. And then I'm going to divide by 3. Add 5, so I write plus 3. Sorry about that. At least I caught it. I'm going to divide by 3. So I could write that as this. That would certainly work. I would write f inverse of x equals x plus 5 all over 3. Or I could write it as 1/3 x plus 5 over 3. Sometimes this is the easier way to think about it. Okay, now what you're going to see when you graph this is this. So to graph that original function, I'm going to have -5. It's going to be a little rough because I don't have the graph paper, but I bet you I'll do okay with it. So -5, then go up 3, 1, 2, 3 over 1. Go up 1, 2, 3 over 1 more. So something like that. Nice line. Now, we've got this point here, 0, -5. We've got this point, which is 1, -2. We've got this point, which I think is 1, no, it would have to be 2, 1. And if we're going to just switch x and y, the old 0, -5 becomes -5, 0. The old 1, -2 becomes -2, 1. The old 2, 1 becomes 1, 2. And we'll graph it. Now, this is what's kind of cool. That point is probably going to be, we did a little bit of algebra here off camera, and I found out that this point, where those two lines intersect, both these equations are solved for y. So I set them equal, and I solved for x. So that point is going to be the point 2.5, and then here's what's really cool about that. The y is also 2.5. The reason that happened is because, remember, we're switching x and y. Well, if these points are intersecting, the x and the y will be exactly the same. And this will happen anytime I'm graphing a function and its inverse, is they'll always intersect on that line, and here's the line, y equals x. So that's one way you can tell graphically if you've done your work right, is that it'll be a mirror image across that line, y equals x. So here's where it starts getting messy. I've got this function x minus 3 quantity squared. Well, that's a parabola. That's the line y, the curve y equals x squared. That's been shifted right 3. If you remember that work we just got done doing. Okay, and it's shifted right 3, so it looks something like this. And the trouble with this function is it's not one-to-one. It fails that vertical line, that horizontal line test. So what will happen if a function is not one-to-one? It doesn't have well, it has an inverse, but the inverse isn't a function. Because what will happen is if we rotate this around the line y equals x, right? It's going to look something like I don't know what it's going to look like. Something I do know what it's going to look like. It's going to look something like this. Let me go to a blue line. So it'll look like this, and that blue curve doesn't pass the vertical line test. So there is an inverse. X and y will switch, but the inverse isn't a function, which isn't always bad, but it's to do much calculus with it, we need to have it be functions. Well, that's not true too, but it's not a function. So what this problem's asking us to do, I'm going to gloss over that. Never mind that for now. So what they want us to do here is restrict this function so that it is one-to-one. So let's take a look at it. So I graphed I graphed that function. I graphed y equals x minus 3 squared on Desmo, and I had it plot a couple points. Now if we're going to switch x and y, and I'm going to graph this to show you what happens. Well, this point becomes 0, 3 on the new function, on the inverse. This point becomes 9, 0 way down here. We can graph some other points. Let's see, that's 4, 1, so this becomes 1, 4. What else we have? We have 2, 1, so I can graph 1, 2. Whoops, 1, 2. Pretend you didn't see that. What else can I graph? Let's see. If I come over 2, say if I come over 2, up 1, 1. If I come over 1, let's see. If I come over, that's a total of 2 points. I'm going to go up there. So that's 5, 4. So switch those. I'm going to get 4, 5. Okay, 4, 5 goes right there. So I'm going to replace some of these things with red ink so I can see what the heck I'm doing. This isn't 4, 5. This is 4, 5. So here's that inverse. We could plot a few more points, but I'm starting to mess up so bad it's probably not worth it. Okay, so here. So this is something what that inverse function looks like. Or inverse looks like. It's not a function. Okay, so what we've got to do is restrict that original function so only one part of this exists. Okay, so let's pretend I'm going to restrict. I'm just going to do this top part, this top curve. So I'm going to erase all of this. And that's going to get reflected around the line y equals x. And I'm only going to look at this part here. Let me get some blue ink. I'm only going to look at this part, I guess. Because if I look at my mirror image, that's the part that's getting reflected, right? So how do you limit the domain? Well, I've just said, because I'm looking at this blue curve here, x has to be greater than or equal to 3. So that's going to be my domain restriction. So, I mean, I could think of, let's just approach this from numbers before we find the equation. So if that's the domain, the range for the original function from that is greater than y is greater than or equal to 0. So now if we're going to switch x and y, the new x becomes the old y, and the old y becomes the new x. And if we take a look at this red graph that I just looked at, the lowest y value on that graph is 3, and then it's going up. The lowest x value on that graph is 0, and then it goes this way. So do you see how that works? And that kind of agrees with our idea about switching and limiting the domain. Find the inverse algebraically. Well, we switch x and y. That hasn't changed. And then I got to unlock the y from the inside the parentheses. So to do that, I got to take the square root of both sides of this equation. And now here's the part that determines what one we use. Well, we were looking for this part. We were looking for that part of the graph right there. Well, to me, that looks like a square root function that's been translated vertically 3 units. So I'm going to go with a positive square root function. So I know I'm going to ignore the negative square root, and that gives me y minus 3. And if I add 3 to both sides, lo and behold, there's my square root function that's been shifted up 3. So that's my inverse on that. Whether we probably ought to put the domain restriction. So the domain, I guess the old domain was x is greater than or equal to 3. This is the inverse of this function on this domain. So here's, I used Desmo to graph it all. So we just did this piece of it. We just did all this piece of it and that piece. What happens if we want to restrict this domain? And something I'm going to ask you in a test is restrict the domain so f of x is decreasing. So that would be this part of the graph. So what part of the blue inverse graph corresponds to that, is reflected around that line y equals x? Well, if you look at this, that's the part that we want. So if you think back to what we just did a minute ago in that video, when I had it to the point of the square root of x equals y minus 3, well, this part here is a square root function that's been shifted up 3 and reflected around the line y equals 3, or around the x-axis. So I'm going to go with a negative, and that's how I know I reflect it around the x-axis, function around the x-axis. And now I'm just going to add the 3 to the other side. Whoops, yeah, so I write square root of 3. Negative square root of x plus 3, and that's y, or f inverse of x on that restricted domain. X is less than or equal to 3. Okay, so I hope that helps. You're going to get plenty of practice with this.